Welcome to part 2 of the chapter Polynomials. Without wasting any time, let's jump straight to the topic. In this session, you will learn about the zeros of a polynomial, also known as roots of a polynomial. Let us try to understand the concept with the help of some examples rather than cramming some boring definitions. So here comes a polynomial px which is equal to 5x cube minus 2x square plus 3x minus 2. What if we replace x by 1? Let's substitute this value of x as 1 in px. Since px is equal to 5x cube minus 2x square plus 3x minus 2, therefore p1 is equal to 5 into 1 cube minus 2 into 1 square plus 3 into 1 minus 2. Now you see, we have simply substituted the value of x as 1. Solving it further, we get 5 into 1 cube is equal to 1, so we have 1 here, minus 2 into 1 square which is equal to 1 plus 3 into 1 minus 2, which equals 5 into 1 is 5 minus 2 into 1 is 2 plus 3 into 1 is 3 minus 2. Now in the next step, we put all the numbers with positive sign together and negative sign together. So we get 5 plus 3 minus 2 minus 2, which is equal to 5 plus 3 is 8 and minus 2 and minus 2 is equal to minus 4. Solving it further, we get 8 minus 4 is equal to 4. Therefore, p1 is equal to 4. How about finding p minus 1? Let's do it. Now, we will substitute the value of x as minus 1 in the given polynomial. So we get p minus 1 is equal to 5 minus 1 cube minus 2 into minus 1 square plus 3 into minus 1 minus 2, which is equal to 5 into minus 1 cube is minus 1. Next, minus 2 into minus 1 square is 1 plus 3 into minus 1 minus 2, which is equal to 5 into minus 1 is minus 5, minus 2 into 1 is minus 2, 3 into minus 1 is minus 3 and minus 2, which is equal to, if you see, all the numbers are negative. So we add all of them together. 5 plus 2 7 plus 3 10 plus 2 12. So we have the result as minus 12. Now let's find px is equal to 5x square minus 3x plus 7 at x is equal to 1. Since px is equal to 5x square minus 3x plus 7, therefore p1 is equal to 5 into 1 square. We have substituted the value of x as 1. Next, minus 3 into 1 plus 7, which equals 5 into 1 square is 1 minus 3 into 1 plus 7, which equals 5 into 1 is equal to 5 minus 3 into 1 as 3 plus 7, which is equal to, again bringing all the positive numbers together, we get 5 plus 7 and the negative number, that is only 1 here, which is minus 3, equals 5 plus 7 is 12 minus 3, which is equal to 9. Let's find qy is equal to 3y cube minus 4y plus root 11 at y is equal to 2. Since qy is equal to 3y cube minus 4y plus root 11, therefore, substituting the value of y as 2 in this polynomial, we get q2 is equal to 3 into 2 cube minus 4 into 2 plus root 11, which is equal to 3 into 2 cube is 8 minus 4 into 2 plus root 11, which is equal to 3 into 8 is 24 minus 4 into 2 is 8 plus root 11, which equals 24 minus 8 is 16, so we have 16 plus root 11. This is the final result for qy where y is equal to 2. Let's find pt is equal to 4t to the power 4 plus 5t to the power 3 minus t square plus 6 at t is equal to a. Yes, we don't have the value here, but we are going to solve this for a constant a. Since pt is equal to 4t to the power 4 plus 5t to the power 3 minus t square plus 6. Therefore, substituting the value of t as a in this polynomial, we get pa is equal to 4a to the power 4 plus 5a to the power 3 minus a square plus 6. Solving it further, we get simply 4a to the power 4 plus 5a cube minus a square plus 6. Later, at any given point of time, when we know the value of a, we can directly substitute the value of a in this result so as to get the final value. Now, let's take a polynomial px such that px is equal to x minus 1. What if we replace x as 1 in this case? Since px is equal to x minus 1, therefore p1 will be equal to 1 minus 1. We have simply substituted the value of x as 1 in the given polynomial. Solving it further, we get 1 minus 1 is equal to 0. Now, here, since p1 is equal to 0, therefore 1 is called as 0 or root of the polynomial px. Similarly, if we consider a polynomial qx such that qx is equal to x minus 2, what is q2? Since qx is equal to x minus 2, q2 will be equal to 2 minus 2. We have simply substituted the value of x as 2 in the given polynomial. Solving it further, we get 2 minus 2 is equal to 0. Now here, since q2 is equal to 0, 2 is known as the 0 or root of polynomial qx, where qx is equal to x minus 2. So, looking at these calculations, in general, we can say that 0 or root of a polynomial px is a number c such that pc is equal to 0. Means whenever we take the variable and whatever value of that variable can get us the value of that polynomial as 0 is known as the 0 or root of that particular polynomial. Now, the question is, how can we obtain 0 of a polynomial? Let's take a polynomial px is equal to x minus 1. To obtain 0 of this polynomial, which is px is equal to x minus 1, we have to equate it to 0. It means px should be equal to 0. Now, here, since px is equal to x minus 1, we can write x minus 1 is equal to 0. Solving it further, we get x is equal to 1. Therefore, for x is equal to 1, px is equal to x minus 1 is 0. Therefore, px is equal to 0 is a polynomial equation and 1 is the root or 0 of the polynomial equation Px is equal to 0. We can say that 1 is the 0 of the polynomial x minus 1 or 1 is the root of the polynomial x minus 1. Now, let's consider 7. You know that 7 is a constant polynomial. So, 7 can be written as 7 into 1. Why? Because a number multiplied by 1 always gives us the same number, which can also be written as 7 into x to the power 0, since a to the power 0 is equal to 1. So we have simply replaced 1 with x to the power 0. So now, what is the 0 root of 7? It means by which value shall we replace x so as to get it reduced to 0 in this constant polynomial. Let us try to understand it in a better way. If x is equal to 1, 7 can be written as 7x to the power 0, which is equal to 7 into 1 to the power 0, which equates to 7. Next, if we take x is equal to 2, then 7 into x to the power 0 can be written as 7 into 2 to the power 0, which again equates to 7. Next, if we take x is equal to 3, then 7 into x to the power 0 can be written as 7 into 3 to the power 0, which is equal to 7. Since a to the power 0 is equal to 1, whether we write 1 to the power 0, 2 to the power 0, 3 to the power 0, all the values are 1, and 1 multiplied by 7, we get 7. So, the result in this case is not dependent on the value of x. So, we are not getting 0, no 0. Why? It is already clear. It is simply because x to the power 0 remains 1, irrespective of whatever is the value of x. Therefore, a non-zero constant polynomial has no 0 or root. Now, what about zeros of the 0 polynomial? In order to understand this, let us take the 0 polynomial. We have already learned that it is 0. Now, let us multiply this 0 with x to the power 0, then x to the power 1, then x to the power 2, then x to the power 3. What is the result? It is 0, simply because any number multiplied by 0 always gives us 0. So, whatever the value of x, the value is always 0. It means for any value of x as a real number, it is a 0. Therefore, we can also say that every real number is a 0 or root of the 0 polynomial. You can pick up any real number, and in case of 0 polynomial, you will always get the result as 0. If Px is a linear polynomial, Px is equal to ax plus b, where a is not equal to 0, how can we find a 0 or root of Px? Now, for 0 of Px, Px should be equal to 0. Since Px is equal to ax plus b, and for 0 of Px, Px should be equal to 0, it means ax plus b should be equal to 0. Solving it further, we get ax is equal to minus b by taking plus b on the right hand side of equal. Next, by cross multiplication, we get x is equal to minus b by a. Therefore, x is equal to minus b by a is the only 0 of Px, where Px is a linear polynomial. It means A linear polynomial has one and only one zero or root. So we can say that a linear polynomial px is equal to ax plus b, where a is not equal to 0, has one and only one zero or root, which is x is equal to minus b by a. Now let us take some examples to understand this concept better. Our first example is, if fx is equal to 2x cube minus 3x square plus 5x minus 7, find f2. Since fx is equal to 2x cube minus 3x square plus 5x minus 7, therefore, substituting the value of x as 2 in this polynomial, we get f2 is equal to 2 into 2 cube minus 3 into 2 square plus 5 into 2 minus 7. See, we have simply substituted the value of x as 2 in the given polynomial. Solving it further, we get 2 into 2 cube is 8 minus 3 into 2 square is 4 plus 5 into 2 minus 7 equal to 2 into 8 is 16 minus 3 into 4 is 12 plus 5 into 2 is 10 minus 7. Now arranging all the positive numbers together and negative numbers together, we get 16 plus 10 minus 12 minus 7. Solving it further, we get 16 plus 10 as 26 and minus 12 minus 7 as minus 19, which is equal to 26 minus 19 is 7. Our next example says, if fx is equal to 7x square minus 3x plus 8, find f of minus 1 and f of 2. Since fx is equal to 7x square minus 3x plus 8, therefore, substituting the value of x as minus 1 in this polynomial, we get f of minus 1 is equal to 7 into minus 1 square minus 3 into minus 1 plus 8. Solving it further, we get 7 into minus 1 square is 1 minus 3 into minus 1 plus 8, which is equal to 7 into 1 is 7, minus 3 into minus 1 is plus 3 and plus 8, which is equal to 7 plus 3, 10 plus 8 is equal to 18. Now getting to the next part of this question, we substitute the value of x as 2. Thus, f of 2 is equal to 7 into 2 square minus 3 into 2 plus 8, which is equal to 7 into 2 square is 4 minus 3 into 2 plus 8, which is equal to 7 into 4 is 28 minus 3 into 2 is 6 plus 8, which is equal to 28 plus 8, collecting all the positive numbers together, and then we have minus 6, which is equal to 28 plus 8 is 36 minus 6, which equals 30. Now let's get back to our next example, which says, if fx is equal to 2x cube minus 13x square plus 17x plus 12, find f of minus 1 by 2. So let us solve it. Since fx is equal to 2x cube minus 13x square plus 17x plus 12, therefore substituting the value of x as minus half in this polynomial, we get f of minus 1 by 2 is equal to 2 into minus 1 by 2 to the power 3 minus 13 into minus 1 by 2 to the power 2 plus 17 into minus 1 by 2 plus 12. Solving it further, we get 2 into minus half cube is minus 1 by 8 minus 13 into minus half square is 1 by 4 plus 17 into minus half plus 12. Solving it further, we get minus 2 into 1 by 8 minus 13 into 1 by 4 minus 17 into 1 by 2 plus 12. In the first term, 2 cancels out 8, 2 ones are 2 and 2 fours are 8. Now, in the next step we get minus 1 by 4 minus 13 into 1 is 13 upon 4 minus 17 into 1 is 17 upon 2 plus 12. 12 can also be written as 12 upon 1. Now, taking LCM of the denominators, we get 4. So, 4 ones are 4, 1 into 1 is minus 1, 4 ones are 4, 1 into 13 is minus 13, 2 twos are 4, 2 into 17 is minus 34, 1 fours are 4, so 4 into 12 is equal to 48. Now, in the next step, we get minus 1 minus 13 minus 34. This gives us minus 48 and we already had plus 48 divided by 4. Minus 48 plus 48 is 0 divided by 4, which comes out as 0. Thus, we can conclude that minus half is the 0 of this polynomial. Our next example is, if fx is equal to x cube minus 6x square plus 11x minus 6, find p of 1. Let us solve this one also. Since fx is equal to x cube minus 6x square plus 11x minus 6, substituting the value of x as 1 in the given polynomial, we get f of 1 is equal to 1 cube minus 6 into 1 square plus 11 into 1 minus 6, which is equal to 1 cube is 1 minus 6 into 1 square is 1 plus 11 into 1 minus 6, which is equal to 1 minus 6 plus 11 minus 6. Collecting all the positive terms together, we get 1 plus 11 and negative terms minus 6, which is equal to 12 minus 12, which results in 0. So here we can conclude that 1 is the 0 or root of this polynomial. Now let's quickly jump over to our next example. Check whether minus 2 and 2 are zeros of the polynomial x plus 2. So the solution would be, let px is equal to x plus 2. Now, in order to find the value of p minus 2, we have to substitute the value of x as minus 2. Therefore, p of minus 2 is equal to minus 2 plus 2, which is equal to 0. And p of 2 is equal to 2 plus 2, which is equal to 4. So you can see we have got 0 in case of p minus 2, but 4 in case of p2. Therefore, we can clearly state that minus 2 is a 0 or root of the polynomial x plus 2. Now here, we have one more reason why we got only one root for the given polynomial. You see, x plus 2 is a linear polynomial. And a linear polynomial has one and only one 0 or root. So when we got one root, p minus 2 is equal to 0, we know that there could not be any other root for this polynomial. Our next example says, find a 0 of the polynomial px is equal to 2x plus 1. In order to find 0 of a polynomial, it has to be equated to 0. Therefore, px should be equal to 0. Since the value of px is 2x plus 1, we can write 2x plus 1 in place of px. Thus, we get 2x plus 1 is equal to 0, which implies 2x is equal to minus 1. Solving it further, we get x is equal to minus 1 by 2. Thus, minus 1 by 2 is the 0 of polynomial 2x plus 1. Let us also look at an alternate method. Since We know for a linear polynomial ax plus b is equal to 0, where a is not equal to 0, the 0 or root x is equal to minus b by a. We have already seen this earlier. Now, since 2x plus 1 is equal to 0 and the standard form is ax plus b is equal to 0. Comparing the two, we see that a is equal to 2 and b is equal to 1. Since 0 or root of x is equal to minus b by a for a standard linear polynomial, therefore for 2x plus 1, 0 root will become x is equal to minus 1 by 2. We have simply substituted the value of a and b as mentioned above. You see, we have the same answer even when the methods are different. So, as long as you follow the right methods, right procedures, irrespective of which method you are following, you always get the same result. Our next example says, verify whether 2 and 0 are zeros of the polynomial x square minus 2x. Let us solve it quickly. Let px is equal to x square minus 2x. Now, in order to find p of 2, we have to substitute the value of x as 2 in the given polynomial. Therefore, p2 is equal to 2 square minus 2 into 2, which is equal to 2 square is 4 minus 2 into 2 is 4. Solving it further, we get 4 minus 4 as 0. Next, we have to find the value of p0. So let us substitute the value of x as 0 in the given polynomial. So we get p0 is equal to 0 square minus 2 into 0. 0 square is 0 minus 2 into 0 is also 0. Therefore 0 minus 0, the result is 0. Thus 2 is a 0 or root of the polynomial x square minus 2x. Also 0 is a 0 or root of the given polynomial x square minus 2x. Hence verified. Our next example is, if x is equal to 4 by 3 is a root of the polynomial fx is equal to 6x cube minus 11x square plus kx minus 20. Find the value of k. Now this question is a bit different from the questions we have solved so far. But believe me, this is not complex. You just have to solve it the same way. Use the same basic concepts that you have learned and we will have the answer very quickly. So let us solve it. Since x is equal to 4 by 3 is a root of the given polynomial, which is fx is equal to 6x cube minus 11x square plus kx minus 20. Since 4 by 3 is the root, therefore f of 4 by 3 must be equal to 0. So, substituting the value of x is equal to 4 by 3 in the given polynomial, we get 6 into 4 by 3 to the power 3 minus 11 into 4 by 3 square plus k into 4 by 3 minus 20 is equal to 0. Solving it further, we get 6 into 4 into 4 into 4 as there was 4 cube divided by 3 into 3 into 3 as there was 3 cube minus 11 into 4 into 4 upon 3 into 3. Why 4 into 4 and 3 into 3? Because there is a square of 4 by 3. Next, plus k into 4 by 3 minus 20 is equal to 0. 3 ones are 3 and 3 twos are 6. So we get 2 into 4 into 4 into 4 as 128 divided by 3 into 3 is 9. Minus 11 into 4 into 4 is 176 divided by 3 into 3, 9. Plus k into 4 is 4k divided by 3. Minus 20 is equal to 0. Solving it further, we get 128 by 9 minus 176 by 9 plus 4k by 3 is equal to 20. We simply took minus 20 from LHS to the RHS of this equal sign, and thus the sign changes from minus to plus. Taking the LCM of all the denominators, we get 9. Solving it further, we get 9 ones are 9, so 1 into 128 is 128, minus again 9 ones are 9, 1 into 176 is 176, plus 3 3s are 9, therefore 3 into 4k is 12k, which is equal to 20. Now in the next step we do the cross multiplication, thus getting 128 minus 176 plus 12k is equal to 20 into 9. Solving it further, we get 128 minus 176 as minus 48 plus 12k is equal to 20 into 9 is 180, which implies 12k is equal to 180 plus 48. In the next step, we get 12k is equal to 180 plus 48 as 228, and further we get k is equal to 228 by 12. Now here 12 cancels out 228. 12 ones are 12, remainder is 10, there is 8, so it becomes 108, and 12 nines are 108. Therefore k is equal to 19. See how easy it was to solve this question as well. Now let us quickly move ahead to our next example. If x is equal to 2 and x is equal to 0 are roots of the polynomial fx is equal to 2x cube minus 5x square plus ax plus b. Find the values of a and b. Looks complex? Don't worry, it is not. Let us solve it. Since f of x is equal to 2x cube minus 5x square plus ax plus b, and x is equal to 2 is a root, it means f of 2 must be equal to 0. Therefore, substituting the value of x as 2 in the given polynomial, we get f of 2 is equal to 2 into 2 cube minus 5 into 2 square plus a into 2 plus b is equal to 0. Solving it further, we get 2 into 2 cube is 8 minus 5 into 2 square is 4 plus a into 2 is 2a plus b is equal to 0. Next step gets us 2 into 8 as 16 minus 5 into 4 as 20 plus 2a plus b is equal to 0. Further, we get 16 minus 20 as minus 4 plus 2a plus b is equal to 0. Taking minus 4 on the RHS of equal to, we get 2a plus b is equal to 4. So here we got one expression where we have the value of 2a plus b as 4. Let us name this equation as 1. Since x is equal to 0 is also a root, it means f of 0 must also be equal to 0. So let us substitute the value of x as 0 in the given polynomial. So we get f of 0 is equal to 2 into 0 cube minus 5 into 0 square plus a into 0 plus b is equal to 0. Solving it further, we get 2 into 0 cube as 0 minus 5 into 0 square again 0 plus a into 0 again 0 plus b is equal to 0, which means b is equal to 0. Now substituting the value of b is equal to 0 in equation 1, we get 2a plus 0 is equal to 4. Solving it further, we get 2a is equal to 4, which is a is equal to 4 by 2 by cross multiplication. Here 2 cancels out 2. 2 1s are 2 and 2 2s are 4. Therefore, a is equal to 2. We already got the value of b as 0. Therefore, a is equal to 2 and b is equal to 0. Thank you for watching and learning, and I hope you are practicing too. Also, keep solving the questions rather than simply sitting and watching these sessions. Practice will help you gain a better understanding of the concepts explained in the sessions, and then only you can perform better in your exams. Join the next session to understand and learn the concepts of remainder theorem, which is an important part of this chapter, Polynomials. I will be explaining the concepts with the help of many relevant examples. I will help you understand all the fundamental mathematical concepts in your course, as that will prepare you to find the solutions yourself, resulting in better marks in your exams. Furthermore, I will also help you understand different methods, will share many simple tips and tricks to help you develop a mindset which is ready with problem solving attitude. Subscribe the channel to get notified as soon as the next session goes live. Although you are advised not to subscribe the channel if you don't want to practice. You can't learn maths by simply watching this or any other video or tutorial. You will be merely wasting your time. Maths is all about the clarity of concepts and practice. Subscribe the channel, like the video if you are in love with maths, or at least you are ready to fall in love with maths. Appreciate the efforts behind delivering the sessions only and only if you really mean it. If you keep understanding and practicing, you will be able to solve all these problems yourself, even in your examinations. Remember, the more you practice, the more you learn. Please leave your queries, if any, in the comments, and I will try to cover it in the upcoming sessions. Believe me, study mere, not anymore.